So let us take the subject mathematics for first PUC, and in that particular we will go to the chapter 1 on sets. So here we will go directly to the exercise number 1.1, and in that we will attempt the question number 6. So question number 6 so reads like this. So match each of the set on the left in the roster form with the same set on the right described in the set builder form. So here now you try to understand this particular question. So they have given a set of elements in the roster form on the left hand side of the column, and on the right hand side you can see that the same set are so described in the set builder form, so but it is changing in the order. So but what you have to do is match each of the set in the roster form and in the set builder form, so which describes the same set in these two columns. So now, so let us try to find the solution for this. So the solution so states like this. So here you can see that in the first item you have on the left hand column in the roster form, you can see that it contains a set of all elements 1, 2, 3, 6. And here if you try to see in the second column in the set builder form, you can see that the item number C, here you can read like this: a set containing all x such that x is a natural number and divisor of 6. So when you try to identify these two sets, so that is 1 and C, so you can see that both these are matching. So first you try to identify the set 1 with A. So here it is a different set, so that x is a prime number and a divisor of 6. So here, so this doesn't match with item number 1. And similarly going to the item number B, where so containing all x such that x is an odd natural number less than 10. So this also so does not match with 1. And D also doesn't match, so because x is a letter of the word mathematics, so this also does not match. But here you can see that the item number C so clearly matches with the item number 1. So therefore all the elements of this set are natural numbers as well as divisors of 6. So therefore 1 matches with C. So I think it is clear. So you have to, so what you have to do is observe the elements in the roster form. So what are the elements in the roster form? You have to observe one by one and check whether it matches so on the right hand side column, so which is given in the set builder form. So when you try to read out so different sets in the set builder form, so then you can identify and match what is given in the left hand side in the roster form. So this is how you have to match the sets so that are given in the both these columns. So similarly in the same way, so considering the item number 2, on the left hand side of the column you can see a set containing elements 2, 3, and try to identify and match this set with the set so which is described in the set builder form on the right hand side of the column. So here you should try to observe, so already so this 1 has matched with C. So now you are left with 3 items, that is A, B and D. So if you look at the item A, where it is a set of all x such that x is a prime number and a divisor of 6. So this clearly matches with the left hand side what we have noted, so that a set containing elements 2, 3. So now if you observe so clearly and so check the other items of the set on the right hand side, you can see that in the item number B, you can see that a set of all x such that x is an odd natural number less than 10. So this doesn't go with the item number 2. And similarly, so this also does not go with item number B also. So therefore, we can clearly tell that 2 matches with the item A. So because on the left hand side you can see a set containing 2 comma 3, and this clearly matches with A, where it reads that a set of all x such that x is a prime number and A is a divisor of 6. So now, so it can be seen that 2 and 3 are prime numbers and also they are divisors of 6. So therefore we can tell that 2 matches with A. And similarly, considering the third one, so where you can see that in the third item you have the set so containing elements M, comma A, comma T, comma H, comma E, comma I, comma C and S. And if you observe, so now already you are so left out with A and C. So you are left out with only B and D. So if you check the item number B, where it reads that a set of all x such that x is an odd natural number less than 10. So this doesn't go with the item number 3. But item number D, if you read on the right hand side, a set of all x such that x is the letter of the word mathematics. So here you can see in the letter of the word mathematics of a set, where you can see that the letters M are repeated and also the letters A are repeated and also the letter T are repeated, so that you can write the set in the set builder form as MATHEICS. So now this matches with the item number 3 on the right hand side. So therefore we can tell that all the elements of the set are letters of the word mathematics. So therefore 3 matches with D. So I hope it is clear. And coming to the last item, that a set containing elements 1, 3, 5, 7, 9. So now you are left with only the item number B, where it reads that a set of all x such that x is an odd natural number less than 10. So now what is required here in the roster form, that the elements 1, 3, 3, 5, 7, 9. So this matches with the item number A. So we can clearly tell that, so that 4 matches with B. So that means all the elements of the set are odd natural numbers and they are less than 10. So therefore we can tell that 4 matches with B. So this is how we have to match the sets in the 2 different columns. So here the first step is to observe the sets given in the roster form on the left hand side and the set given in the set builder form on the right hand side. So after you observe these 2, so take one by one. So if you take the first one, or the item number 1, here you see the elements, so 1, 2, 3 and 6. So first you try to read so what this set or what elements are contained in this set. So once you are aware that what are the elements of this set, so then you try to match this so in the column D on the right hand side, so which is described in the set builder form. So like that you can so match each and every item so given on the left hand side with the same set on the right hand side. So follow the same rule so that you will be able to match all the elements in both the columns, so which are same sets. So now let us so take to another type of the set, so described as the empty set. So now here in this empty set, so you will try to understand so what is the meaning of an empty set and what elements does an empty set contain and what are the characteristics of a empty set. So now first of all let us try to understand the meaning of an empty set. To understand the meaning, so here we will take the first example or consider the set like say set A, so consisting of all elements of X such that X is a student of class 11 presently studying in a school. So this is given in the set builder form where the X is a student of class 11 presently studying in the school. So now we can clearly tell that we can go to the school and count the number of students that are presently studying in the class 11 so that we can get a finite element, and therefore the set A contains a finite number of elements. So how we can tell a finite number of elements? Because we can go to the school and count how many students are there in the class 11, so who are studying in this particular school. And if you consider another set B where it contains all X such that X is a student presently studying in both the classes 10 and 11. So this set is describing that the student is presently studying in both the classes 10 and also in 11 simultaneously. So now in the set A you have observed that it contains a finite number of elements, but in set B if you consider that a student cannot simultaneously study in both class 10 and 11. So therefore you can observe that a student cannot simultaneously study in both the classes, so 10 and 11. So therefore we can tell the set B contains no element at all. So because no student can study in both the classes 10 and 11 simultaneously. So therefore we can tell that the set B contains no element at all. So now we tell that the set B is a empty set where there is no element at all. And now coming to the definition number 1, so for the empty set, so it describes that a set which does not contain any element is called a empty set or a null set. So this is what we have found out in this example. So in this example of the set B, so we have found out that no elements can be present in an empty set. So therefore in this definition you can clearly tell that a set which does not contain any element is called a empty set or a null set or a void set. And according to this definition, B is an empty set while A is a non-empty set. So because in the set A you can see that there are some finite number of students presently studying in the class 11, so it contains some finite number of elements. So that means we can tell that A is not an empty set while B is a null set or a empty set. And the empty set is denoted by the symbol phi, or in braces you can write with no elements like this. And few examples of the empty set is described here. So let us consider the example number 1 where it tells that let set A is equal to, so consisting of all X such that X lies between 1 and 2 and X is a natural number. So this is how this set has been described, and the criteria for that is the value of X lies between 1 and 2 and it is a natural number. So while you observe this particular rule or criteria in which you have to write the elements of this set, so this becomes an empty set. So because there is no natural number between 1 and 2. So here they are given so that the elements of this set should be natural number and also it should be lie between 1 and 2. So clearly you can tell that A is an empty set. So because there are no natural numbers which lie between 1 and 2. So I hope you are clear with the understanding of an empty set. And similarly if you consider the second example where it describes that a set B consisting of all X such that X square minus 2 equal to 0 and X is a rational number. So this is how the set has been described, and here if you see that this set B is also an empty set, so because the equation x square minus 2 equal to 0 is not satisfied by any rational value of X. So if you give any say rational values as the values of x, and you can check that x square minus 2 so will not be equal to so this the value of 0. So therefore we can tell that so B is also an empty set. And similarly, if you go to the third example, where so let C is equal to a set containing all x such that x is an even prime number greater than 2. So then C is also an empty set, because here you can observe that x is an even prime number greater than 2. So but we know that only 2 is the only even prime number. So but it cannot follow the second condition that the even prime number should be greater than 2. So in this case we can tell that this is also an empty set. And similarly, if we go to the question number 4, it describes that a set of all D such that it contains all elements of x such that x square equal to 4 and x is odd. So here also you can tell that so x square is equal to 4, or x we can tell that say values of 2, or it may be of minus 2. So this is how you can describe. So when you take the values of 2 and minus 2, so that it satisfies the equation x square equal to 4. So but the other condition, so that it is odd value of x. So here you can see that x can take only even values and it cannot take any odd value to satisfy the equation x square equal to 4. So therefore there are no elements in this particular set, and therefore it is called as a null set or a empty set. So I hope it is very clear, so that you can describe so what is the meaning of a null set and or what is the meaning of a empty